Okay, so now in the last class, what and all we were seeing is we saw how do we create a container, create a container, stop a container, start a container, and then how do you attach back to a container? That's what we were seeing. And then how do you create image out of it? And how do we create image using Dockerfile is what we were seeing. Now, the remaining topic is about the registry server, or where exactly are you going to store all these images. Now, practically, if you see, we were trying to download or pull the images from the open source from where Docker is giving all those images. For example, if you remember, I started using the Ubuntu, right? Now, all those things are being taken from directly from the registry which is available in the open source. So now, other than that, we can have our own registry. Now, say there are multiple ways of doing it. So, just like GitHub, we also have something called as Docker Hub. So you can have a online, particular account into this Docker Hub, and you can try to store. Or the other simplest way, what we can do is we can have our own registry server on our host itself. That means wherever that we are running the Docker, we can create a simple Docker registry so that we can store all the images that whatever we are creating in the same machine where the Docker engine is running. So what exactly is this Docker registry? So Docker registry is the repository where we will be storing all the images that we are going to create. And what you need to understand is the registry, whatever that we are going to create in our machine, is actually going to act as a volume or a directory inside a container. So pretty much for that, what we need to do is we need to create a what? A container with a specific volume inside it. And that is how whatever images that we are going to store, it's actually going to act as a directory and a volume. So internally, it will be trying to store all those images in that container. Okay, so that is what we are going to do. So how exactly are we going to create a container for our registry server is next thing. So the first thing what we need to do is we need to understand that there is a specific image called registry. Okay, so the purpose of this image is to help us to set up a particular registry, to set up a registry on a particular server where we are running. Okay, so we don't have to spend time in doing it, or we don't have to use any online uh, specific services like, as I said, Docker Hub. Now, instead of that, you can set it up on our own machine. So just like Ubuntu, whatever that we saw, right? The registry is a specific image that is available in the Docker, which will help us to set up the registry server. Okay, so now if you see, I'm giving this option as registry colon 2. So the first thing here is registry is the name of the image, and 2 is nothing but the label attached to it. Because whenever you're trying to change an image and try to push that. So for example, until the previous class, if you see, we were trying to create many images of the same type, right? I had a single Docker file, and for every time I was showing you something, I was trying to build a new image. But practically, if you see, all these images are coming from the same Docker file. So in that case, what you can do is you can have one image name, but you can tag multiple names for that, so that the same image will have different content with different tag names. Okay, so in that way, registry colon 2 is nothing but the name of the registry is the name of the image is registry, whereas 2 is the tag name. That means second time they might have updated it. So that is the latest version or the latest available registry image. Okay, now other than that, we know Docker run means it is going to create a container, and -d means we are going to run this container as a daemon process. That means we will not be going inside the container, it will be running in the background. And -p means what? -p 5000 means it is going to create a container. In that container, it is going to run this registry server using this port number, and the same port number we will be accessing through 5000 from our host machine. That is what it means. Then there is another option for run called restart. Now restart equal to always means whenever you are trying to connect to this particular container, allow them to run the registry automatically. That is what it means, restart always. Okay, and after that we know that -name will give the name for the container, and the name of the container is registry itself. And finally, what is the image that you're going to use? This is the image. Okay, and now if you note, we are not giving a entry point because we are not interested to go to the container and do some task, right? We are just interested to create this container wherein that will have a registry server running. So for that reason, we don't need to give a entry point. Okay, that is fine. So first, let us try to run this. Okay, now Docker is running. Fine. The first thing what we have to do is let's create a container. Docker run -d -p. Okay, and name, I'm going to say registry. Okay, and the name of the image is registry 2. Docker run -d -p and colon and restart always and name. Okay, so what happened? Now we started a container called registry and it is running in the background. Okay, so Docker, so you have, now if you see, there is a container called registry running. Okay, and the name of that what we have given is registry, and it is using the image of registry and the second tag in it. So right now if you see, I actually downloaded this image yesterday, so that's the reason it's fast. If not, for the first time when we are doing, this image is not present in my Docker engine, right? So pretty much it will take some time to download. And inside it, if you see, it is automatically running the script whatever it is present in the image. Okay, so now our Docker registry is set, and what is happening, if you look, the container is running a process where that is using the port 5000, and that will be accessible through our host machine using another 5000 port. So that is what we have meant here. So this 5000 is the port of the application that is going to run, and this 5000 is the port of our machine from where we will be connecting it to. So that is what the mapping is specified. Okay, now once that is done, so we are running a container inside which we have our registry. Okay, now how do I exactly put the images into it or get the images from it? So now whenever you're going to access, how is that you're going to access this particular port or machine? So now if this is running in a specific machine, then you need to know the IP address of that particular machine. Okay, so whenever you say the IP address of the machine, okay, so the IP, and in that IP you have to say 5000. So this is how you will be addressing that machine. Now, in the same way, currently if you see, we are using our own machine itself. So simply we can say localhost 5000. That means it will try to connect to our own machine, and in that machine the port 5000. Now, whenever you are trying to point to a registry, you will try to tell which is the machine on which the registry is there, and in that which port on which it is running. Now, along with it, you have to tell the name of the image. So how you're going to tell the name is by giving a slash n. So this is how you will be addressing. So until now, if you see, whenever I was referring to an image, I was just directly referring to Ubuntu. Now, this was by default pointing to the registry server that is available in the open source. Now, going forward, if you want to specify or point to the registry server which is running in your machine, then you have to specify using localhost 5000. This is because we just created a container where we have mapped the port 5000 from that container to our machine. So this is how we'll be accessing it. Now, once we have created this container, registry server is running. Now, the only thing is, whenever we have created a new image, we have to put our image into it, right? So now, before we put the image into it, it is not just directly, push the tag from, push the container or the image from your server to that particular registry server. Now, the first thing what you need to do is you need to tag, or you need to give a reference of a particular image into the container or into that registry server whatever is running. So that is the first thing that you have to do. So now if you have any image in your local machine that you have created, and if you want it to be stored into that registry server, now the first thing you have to do is create a reference. So that reference is nothing but creating a tag. So how do we create a tag? So we know that to create a tag, we will say Docker tag and the name of the image and what is the tag name, right? So that is what we were trying to do. You remember when we were trying to do a Docker commit. So we did the same thing. So the difference was what? When we did the commit, we created a image from it. So we used to say Docker commit and a container ID, right? And from that, we were creating a tag. So in this case, we used to do Docker tag and what? The container ID and then the image name, right? Image ID. This is what we're doing. So that's the same even we are going to apply here. So the difference is we would already have an image. Now, whatever that image that we have locally, the same image will be referred or will be referenced with a different name or the same name inside the registry. So that is what we need to do. So now say we have downloaded the same Ubuntu, right? So we can try to tag that itself, or you can tag pretty much any other one. So we have this, we have so many images with us. So any of the image that you want, you can try to put it up to the registry server. So, so for example, I'll say Ubuntu. Okay. Now this is the image from your machine. You are trying to tag inside the registry server. So what is a registry server, or how do you connect? So that is running in our local host, and in that port 5000, and then slash, what is the name of the tag that you want to put it? Okay. So simply you try to put it. Now, after you have tagged, the next thing what you need to do is actually push the image to that particular registry server to store. So to do that, we will use the command called docker push. Okay, and again, to the docker push, where exactly you're trying to push the image. So directly you're trying to say that this is the place. That means now you have created a reference in the registry server for this image. Now that image will be stored permanently by taking the content from the local machine to there. Okay, so now if you just say docker push, okay, so you see the difference. The first one was just creating a reference. It didn't actually copy the content there. So only when you do a push from your local machine, the same thing is going to get copied, because by creating a tag, you are saying that the image name, whatever that you are creating in the Ubuntu on the registry server, is just a reference of Ubuntu on your local machine, right? So the next time when you say docker push, that is when it will be trying to copy from your machine, that is this Ubuntu, to the registry server. Okay, so now this particular image called Ubuntu is available on your registry, that is localhost. So now you can give this path to anyone else also. Say like in your machine, if you are trying to run Docker and you want to use the image from this particular registry server. So all you have to do is, instead of this localhost here, as I said, you will say the IP address and 5000/Ubuntu. Now that way you will be accessing the registry server which is running on this machine rather than referring to anything else. So how do I know this IP? See, for example, this is the IP of this. So now simply if I say that wherever that I want to run, if I say this, what will happen is from your machine, you will be connecting to the registry server which is running on this particular machine on port 5000. Okay, so that's the difference on how others can access the registry server that you're running. So being a DevOps engineer, you will be creating the registry server and you will be specifying that to others. So whenever others have to use, all they need to know is on which machine you are running the registry and what is the port that you have used for it. Okay, so in the same way, now as I said, if there is some other user who wants to use the image whatever that you have created and you have pushed into a registry server, so how will he get it? So now for him to specifically get it, the first thing what he will say is he will say docker pull. So now from whatever machine that he is working, okay, so he will just simply say docker pull and which machine the registry is running and what is the port in which it is running and what is the name of the image. Okay, so you will get that particular image available in your or downloaded to your local machine. So right now there is no change because that's the same file I uploaded. So it says that the image is up to date. Okay. So like this, you can see what and all or the image that is available, who modified it specifically. So now that is the difference wherein rather than having it on your own machine, you can run it on a server and you can give that path or access to others. So Docker push means what? You are uploading the changes from your machine to the registry server. So to do that, first you have to tag and create a reference. And then whenever you need from whatever machine that you want to download that image, then simply say Docker pull. Okay, so like this, you keep doing Docker push and Docker pull whenever it is needed. So to upload image, you will say Docker push, and to download, you will say Docker pull. Okay, and this particular tag will be done only for the first time when you are creating the reference, because once you have the reference, going forward, all you have to do is just Docker push for every change that you have. So you don't have to keep on doing tag always. Okay, but if you want to create a new version, or if you want to create a new reference for the same image, then you can create another tag. But if not, you can have the tag created only once for the first time, and then you can do the push. So every time you do the push, it will be overwriting the same file. But if you want to keep versioning it or keep different reference, then create separate tag name like what we just saw, like 2, 3, 4, and then you do a push with that specific tag name called 2, so that it will be copied as a second tag name, not on the same image. Getting it? Hello?
Yeah, Adam. Yes,
Yeah,
Adam.
yeah, okay, man. Okay, sir. Thank you, sir.
Sorry? Okay, now if you look, the registry server is running as a container itself, right? So now whenever you want to stop the registry server, what is that we have to do? So simply stop the container itself, because now I'm not running registry server as something separate, because that's the advantage of using Docker. So rather than you installing it somewhere, you can have a container which contains certain applications pre-installed. So that is how you can start the container, where inside that container you will have the application running. So right now, if you say that I don't want the container or I don't want the registry anymore, just simply do a Docker stop that. And when you say registry, what is this? This is nothing but the container that we created. Okay, so now, so there are no containers running. Okay, and again, the last step what you want to do is delete the image. So if you want to delete it, then just simply say docker rm hyphen v registry. So what exactly you are doing here is you are trying to delete the volume that you have created, because the registry server that is going to create basically creates a volume, and it will be stored inside your Docker engine. So whatever images that you have pushed into it will be stored as a volume. So remember, I said regardless of whether you are starting or you're running the container, the particular volume inside a container will still be accessible, right? So now what you have done is you have just stopped the container. That means you cannot do any more push, but still the containers contains the volume inside it. So whatever content that you have put, it's still available on your machine. So finally, if you want to delete that volume also, then just simply say docker rm and -v and specify the name of the volume, which is nothing but the same name as your container. So you're going to delete it. So now it will also delete the specific volume that you have used for your container. Okay, and make sure you do it only once, or you don't even do this. Only for your testing purpose or for your practice you do, but in production you will not be doing this step. In the same way, now we have, now if you see, what is this? We have so many containers that we have, correct? So you can go ahead and run this container or delete this container. That is one. The second thing is, we have so many images. So at any point of time, if you want to remove these images, then simply you can say docker rmi and a specific image name. So now this will be deleting a particular image what you have. Okay, now rather than that, like for my purpose, I want to delete every available image. So if you give an option called -a-q, it will not be giving you the complete output. It will be giving the output in a quiet form. So this is nothing but the name or the ID of each image. For every image, if you see, we will be having a image name and a ID, right? So to delete a particular image quickly, if I will take only the image ID and pass it as an option. So that is what we are going to do. So if I say docker rmi, and in the codes, if I run this, it will try to generate all the IDs that is available in the image, and then it will pass it to docker rmi so that it will delete everything in one shot. So let's run that. Okay, you still have the container. Okay. Fine. So it's saying that the image is being used by that particular container. So now once you delete this container, you can start deleting that also. So either you choose to delete the image one by one, or only for the practice again, this shouldn't be tried every time. This is the command that you will be using to delete the image which you don't want.